Hello everyone, myself Dr. Manjit Borah, Assistant Professor, Department of Physics, Goalpara College. So I am going to take a class on transistor. So although we are speaking as transistor, we are basically going to discuss about bipolar junction transistor, which is the basic form of transistors. So we have further fine or modified or standard transistor like that MOSFET or FET, this kind of transistor. We will not going to discuss about this. That we are going to discuss about only bipolar junction transistor here. So what is bipolar junction transistor? It is basically, I already tell, it is the basic form of transistor, and it is constructed by sandwiching an semiconductor piece, opposite polar semiconductor piece between two same polar semiconductor piece. So we know we have two types of extrinsic semiconductor. We are talking about extrinsic semiconductor here only. So we have two types of extrinsic semiconductor. One is P type, another is N type. So P type semiconductor can be constructed by doping an trivalent impurity to an intrinsic semiconductor, and similarly we know the N type semiconductor can be constructed by doping an pentavalent impurity with an intrinsic semiconductor. So we have these two type of semiconductor. Extrinsic semiconductor, one is N, one is P. So what in case for fabricating a transistor, what we do, we sandwich an opposite polar semiconductor piece, say P or N, between two same polar semiconductor piece, say here N, two same polar piece N, their opposite polar semiconductor is P, and here the two same polar semiconductor is P, and the in between we have sandwiched an opposite polar semiconductor N. So as there are two types of extrinsic semiconductor, so we can construct only two types of transistor, bipolar junction transistor. One is NPN transistor, another is PNP transistor. For understanding, it is okay to look at this diagram, but when we go for circuit, in the circuit we don't use this type of configuration. We use symbol for transistor. So in a transistor, as we have three parts, these three parts. So here we can see this part is larger compared to this part of same polar semiconductor piece, or this part of P is larger than this part of P. So what is this? Actually, this part which is larger piece, this is heavily doped semiconductor. Here this N piece is heavily doped, and here this P piece is heavily doped. Then the other same polar piece, here this P piece and here this N piece, they are lesser doped. So this heavily doped semiconductor piece is called as emitter. This lesser doped semiconductor piece is called collector. In between emitter and collector, we have this piece which we call base. So in a transistor we have three pieces. One is emitter, one is base, and another is collector. So we can give connection to all three pieces. One to connection, the connection which we give to emitter piece is emitter connection. The connection we give to P base is P connection, and base connection or the connection we have given to the collector is collector connection. So we will get three types of current. One is emitter current, which will be measured through this connection to the emitter. Another will be base current, which will be measured in the terminal connected to the base. And another will be collector current, which will be measured in the terminal connected to the collector. So this will be its circuit diagram. So here we can see that there is a arrow mark in this terminal and in this terminal. So when we draw a transistor, it may be NPN or PNP, we give an arrow symbol in the emitter terminal only. And with observing that direction of this terminal, we can say which kind of transistor is this. So if it is an NPN transistor, the current, and we know always that current always moves from positive terminal to negative terminal. In case of NPN transistor, the mid terminal will be P, right? This terminal will be P. So current will move from this side to this side. So here we will use arrow marks will be directed towards outside. And in case of PNP transistor, the mid terminal is and mid portion is N type semiconductor. So current will be directed from outside to inside as current moves from P to N. So in PNP, arrow in the emitter terminal will be towards the center of the transistor, and in case of NPN transistor, arrow will be towards the outside of the transistor. And to remember this, we can remember this to golden line also. So in NPN, never point in, the arrow marks never point in NPN transistor, or PNP, we can say that points in permanently. So to remember these golden lines, that in NPN transistor arrow is towards outside, and in PNP transistor arrow is towards inside. To remember this, we can remember these two line also. So if we say what are use of transistor, actually In all kind of electronic equipment, we are surrounded with all kind of equipments use a transistor. However, in the circuit, it is used as an amplifier. It can be used as amplifier, oscillator, switch, or this kind of thing. And another important point is we are speaking that it is SBJT or bipolar junction transistor. Why we are telling it is bipolar junction transistor? Because here two types of carrier is working for carrying the current. One is hole, another is electron. We know the basic concept of electron. Current flows towards the opposite direction of the flow of electron. And what is hole? Okay. In case of current electricity, current is always conducted by electron. In electricity there is no any mention about holes. But however, in electronics we discuss largely or enormously about holes. What is holes? Holes is actually nothing but absence of electron. So what is happening in a semiconductor, we know we have the conduction band and we have valence band. Electron in the conduction band can carry current, and electron in the valence band cannot carry current. Now when we switch the electron from valence band to the conduction band, then we will get a electron in the conduction band. Okay, but the place where earlier the electron was in the valence band, that place will become vacant. That vacant place or the absence of electron here we will call holes. So when a electron jumps from valence band to conduction band, we get a pair, one pair called electron hole pair. Here the electron will be in the conduction band and the hole will be in the valence band. As in transistor, both electron and holes takes part in the conduction of current. That is why we call it bipolar junction transistor. So in N region, the electron will be majority carrier. In the P region, the hole will be majority carrier. So how it conduct current? To understanding the basics, we are using this configuration here only. So this piece is heavily doped, it will be emitter. This piece is lessly doped, this piece is lessly doped, it will be collector. Then there we have another piece which is opposite polar semiconductor piece. So in a circuit, we have in a transistor configuration we have two circuits. One is input circuit, another is output circuit. As we have only 3 terminals and we have to make one input circuit and one output circuit, definitely we will have to use one terminal both in input configuration and in output configuration. Here using the base terminal in the as common, here base emitter connection will be input configuration. So in a transistor, it is always to be remembered that the input circuit is always forward. So here P will be connected to the positive terminal of the battery, the N will be connected to the negative terminal of the battery. This positive terminal of the battery will push hole towards N. So we will get this emitter current like this. So in the this positive terminal of the battery will push those hole, and certain amount of hole will recombine here in the N region. So due to this recombination, we will get a current which will be base current. Here only 2 to 5% of this majority carrier which is pushed from emitter to the base will be recombined in the base region. Rest of the majority carrier will be moved towards this direction. So here it is also positive terminal. To pull out majority carrier from this terminal to the outside, we will have to connect this output configuration in the reverse bias. That means this positive terminal will be connected to the negative terminal of this battery. So this negative terminal will pull electron. This negative terminal will pull holes from this collector terminal, and so the configuration will be like this. This positive terminal will push hole, and we will get hole current. Certain amount will get recombined in this N region. We will get base current. The rest of the hole will be moved towards this output circuit when we will get collector current. So basically, IE current is getting splitted as base current and collector current. So IE equal to always IB plus IC. That thing I have discussed. These are written here. So it is important. The IE equal to IB plus IC. Now, in this output circuit, although it is reverse bias to the majority carrier, it is always forward bias to the minority carrier. We know what is minority carrier. Minority carriers are electron of this P semiconductor and hole of this N semiconductor. So in P semiconductor, there are a certain amount of minority carriers. For those minority carriers, this reverse bias will be act as forward bias. So along with this IC, we will get a certain amount of current due to minority carrier, and that current will be called as leakage current. So IC actually will have two components, one from this emitter which will be called alpha IE, and another portion is called ICBO or leakage current. What is alpha? We will discuss here. So transistor can be connected in three configuration, where one, in this configuration base is considered as common between input terminal and output terminal. Here the emitter is considered as common between input circuit and output circuit, and here the collector is considered as common between input circuit and output circuit. In this configuration, where base is considered as common between input circuit and output circuit, input current will be emitter current, the output current will be collector current. The current amplification factor will be obviously output current divided by input current. As the output current is IC, input current is IC, the current amplification factor will be IC by IE. We are using alpha symbol to mention that current amplification factor. So alpha equal to IC by IE. So the current amplification factor in the common emitter configuration will be, here the output current will be IC, the input current will be IB. So current amplification will be expressed as beta, and it will be ratio between this output current by this input current. So IC by IB. In common collector configuration, the current amplification factor is expressed as gamma, and it is the ratio of this output current to this input current. These configurations are NPN transistor only. So we can draw this diagram, this circuit in PNP transistor also. This will be common base configuration, this will be common emitter configuration, this will be common collector configuration. So these alpha, beta and gamma are important factors of a transistor. We can determine the relation between this alpha, beta and gamma. For determining the relation, we have just need to remember this relation, IE equal to IB plus IC. That means base current plus collector current is equal to emitter current. So we can use this equation. If we to find out the relation between alpha and beta, what we will have to do? Simply divide this equation by IC. If you divide it by IC, then we will get I by IC equal to IB by IC. Obviously, this IC will get cancelled with IC. So we will get 1 by alpha equal to 1 by beta plus 1. So we will get the relation alpha equal to beta by 1 plus beta. Similarly, we can determine the relation between alpha and gamma, beta and gamma, and this type of relation that can be determined easily. So it have to be, I left it as a home assignment. When you go through this slide, if you understood, then try to determine the relation between alpha and gamma. Now, one most important characteristics of a transistor, or important point of a transistor, if we want to understand the working of a transistor, that will be understanding its characteristics curve. So the characteristic curves will be drawn between, there will be two characteristic curves, one for the input circuit, another will be for output circuit. We are considering common base configuration only. Here, this will be the circuit we will use to determine the characteristic curve. Here, input current will be obviously IE, as it is common base configuration. Input current will be IE and output current will be IC. We are using this emitter to determine the emitter current. We are using this voltmeter to determine the input voltage VEB. We are using this VCB to determine the output voltage VCB, and this emitter will determine the output current collector IC. So through this rheostat, we can vary the input voltage and output voltage. So the input characteristic curve will be between this input current and input voltage IE by VEB. When we and it will be drawn. If we draw, then the circuit will be like this. So input voltage VEB, input current IE. So how to determine the draw the graph? To draw the graph, we kept this output voltage at a constant value, or the output current at a constant value. Then we increase the value of VEB slowly. So it kept at 0, IC kept at 0, then VEB increased slowly, the corresponding value of IE is measured. Then if we plot the graph, then we will get a graph like this. For 0 VCB or 0 collector current. Now for the next set of graph, we will increase the VCB to another value. Say this VCB is increased to 1 volt. Then what we will do? Now we will again increase the value of VEB. The corresponding value of IE will be noted, and if we draw the graphs, then we will get a graph like this. This will be input characteristic curve. So the output characteristic curve will be obviously between output current and output voltage. The output current is IC, the output voltage is VCB. To draw the graphs, what we do? We initially kept the IE value at 0, then we increase the value of VCB, then we observe the change in collector current. It can be seen that with increase in VCB, For initial region, there is a slight increase in IC. However, after that, IC is almost independent of PCB. Then for the next set of graph, what we do, we increase the IE value to say 1 milliampere. Then we again increase the value of PCB and notate the value of IC. Then we will get another graph. So in this way, by increasing IE, we can measure different set of IC corresponding to PCB, and it can be seen that for a higher value of PCB, the IC is always independent of PCB. If we want to increase the value of IC, then we will have to increase the value of IE only. So it will be the output characteristic curve in common base configuration. Similarly, we can draw the characteristic curve for common emitter configuration also. The current characteristic curve will be input characteristic curve will be input current IB and input voltage VB, and the output characteristic curve will be output current IC and output voltage VCE. As it is common emitter configuration, input current will be IB and IE will be common. So here also, with increase in input voltage, the value of input current increase like this, and the output current obviously here also almost independent of this VCE. If we want to increase the value of output current, then we will have to increase the value of input current. In this curve, however, this 3 region is important. This region is saturation region, this region is active region, then this region is cutoff region. The region in which we cannot get the output current, because for IB equal to 0, this amount of current we will obviously get. So a transistor normally used in this active region only. Actually, if we want to use it as the amplifier or like this kind of use, then we will use in this active region only. Okay.